The final thing we're going to talk about in this unit is the switch. Switches are circuit elements that turn a circuit on or off. You've probably used many of them before. For example, a light switch is modeled in the same way as the switches we'll be talking about today. Why I want to talk about them is because they control the timing of a circuit. So anytime we ask a question that involves time, for example, how much energy is used by a circuit, and there's a switch involved, we have to be very careful about when the switch opens and when it closes. The circuit diagram for a switch is this. Even if it's a closed switch, it's typically given with this symbol. It indicates something that can open or close. Sometimes in the book, and also in certain other assignments, you'll see it drawn open and then a circuit is redrawn with the switch closed. This is primarily for clarity. You won't actually ever see this when you're building a real circuit. I'm going to stick with the idea of having it open when it's open and then redraw the circuit when it's closed with the switch as just a wire in order to make it easier for us to understand what's going on in the circuit. But please don't take that to mean that that's how switches should be drawn. So let's take a quick example to see what happens when we are dealing with a time-based problem that involves switches. Here's a circuit, and there's not much to it. This is going to be a resistor and a voltage source. We'll make it a 1 ohm and a 1 volt. And we would like to know how much energy is consumed by the resistor. Well, we can't answer this question until we know when the switch is closed and when it's open again. So typically we give additional information. The switch closes at t equals 0, and it opens at t equals to 3 seconds. Now we can start to answer this question. Like I said, for clarity purposes, I will draw the circuit when the switch is closed. What that looks like is this. So, when a switch is closed, it's just a wire. And this circuit is going to be what the circuit will look like from 0 to 3 seconds. So, we can now begin to ask the question, how much voltage is in that resistor, how much current is in that resistor, then we can ask the question of how much power and therefore how much energy. We're going to do this in stages. In this case, I have a current, I, which will be equal to 1 amp by Ohm's law. Remember, if I have 1 volt across a 1 ohm resistor, I'm pushing 1 amp through it. This means that the power in the resistor is V times I times the sign, and remember in the resistor the sign is always positive 1, which gives me 1 watt, 1 amp times 1 volt, positive. The energy is the integral from T1 to T2 of the power times dt. And this is where the switch becomes important. T1 is when the switch closes. In our case, it was 0 seconds. T2 is when it opens. In our case, it was 3 seconds. So now we can rewrite this. The energy is the integral from 0 to 3 of 1 watt dt, which is given as 3 joules. So, although switches might sound simple, that they're just open or closed, the key to understanding them is that they affect when things happen in a circuit. So when we're dealing with questions of timing, we have to look at when our switches are open and when they are closed.